Hi everyone, welcome to the Kotlin London Meetup. So last month we kicked off our online meetups for keeping providing content while we were in lockdown. Luckily things are improving, but we're not out of the woods now. So there's still quite a lot to do before we'll be able to go meeting physically in meetups hosted by all of many companies in London that want us to host our meetup. So for now, our commitment is to keep going on with live events. And we were very nervous before our first event last month because the one had never organized live streaming before. But everything went so smooth. And thanks also to our speakers, of course, have been amazing. In fact, we decided not only to do it again, but also they wanted to do it more. Uh, at first, our commitment was to, as originally planned, to do a meetup every 2 months. But after that, the first event, we said, okay, let's do it monthly. We can do it. Let's do it. So here we are. So yeah, expect like every first week of the month, a new Kotlin London meetup. If you haven't done it yet, join our meetup page, hit subscribe to our YouTube channel, and follow us on Twitter to be notified when a new event is coming up. All the info are in the description of this YouTube event. Just a bit of housekeeping before starting. First, we would like to thank 47 Degrees because last month they provided us 2 speakers. Have been amazing. They went very, very smooth, everything. And soon they are going to launch their online learning platform. So fingers crossed for them and good luck. Follow them on Twitter at 47deg to get all the info. We also would like to thank the Leeds Kotlin user group because they share this event on social media. They help to spread the word. And we definitely, if you have a community, please share our events through your community. It really helps us to build a larger community. We have like 100,000 new subscription on our meetup page every week, and it's like really amazing. We are really going global, and it's amazing. Last but not least, I'd like to send the congratulations to our co-organizer, Pablisco, because he cannot be with us tonight because it just became a dad. So congratulations to him. He's obviously busy. So yeah, just congratulations. Right. Okay, as usual, tonight we have 2 talks. Our first speaker is Hardik Trivedi. He's Android developer Globan. He talk about he's giving us an introduction to Kotlin Flow. Our second speaker is Sebastian Aigner, who is developer advocate at JetBrains, and he will talk about full stack web web application with Kotlin. Of course, we have to thank them because they accepted to speak at our meetup and being with us tonight. The Q&A will be done after each talk. The speaker will read the question and will answer. If they compare to the Slido, we use Slido, and the link for asking a question is in the description of this event. During and after the talks, please add a small feedback in the comment section, even just a thumbs up or a clap emoji. It's just enough. It's nice for the speaker to have some sort of like a feedback and acknowledgement, because sometimes the silence on an online event can be scary. So that's it for me. I'm introduce our first speaker, who is Hardik Trivedi. We talk about like an introduction to Kotlin Flow. It's up to you, Hardik.
Hello everyone. Thanks Enzo for the introduction. And thanks all for joining on this call. I hope you and your near and dear ones are keeping well in this pandemic situation. In this time, basically, we all, learn lots of new skill, and I am no exception to it. I was experimenting around flow and finding out possibility of using flow in my company project, and also I also doing some research for one of my published book on Android and Kotlin, and I would be sharing my learning with you all today. So without further ado, let's start it. So why we should use Flow as an Android engineer, or maybe as a Java engineer, which you are maybe familiar with Kotlin? You might be asking, why should I use Flow? There is already coroutine, and there is also channel available, and of course there is great RX Android or RX Java, the beast. So why should I think about Flow? So here is few points which I would like to share with you, and maybe you would convince. So coroutine is more around structured concurrency, and it goes. It does not go well with managing stream of data. It's not just uh, it can't manage the stream of data, and it is more time taking if you would like to achieve just with the pure coroutine. So many times you simply need to manage stream of data, but something asynchronous, which you would like to do as a in your non-blocking thread. So that's where flow comes in a picture. It has got that same power. But then there is Rx, and Rx is very rich in terms of operators, um, and a lot of other features are there. It is already proven, people are using in production since years. So these are the reason people would like to stick with Rx. But Rx has got learning curve as well. So thinking from a newbie perspective, Rx has a quite a good learning curve. And flow is cold. So we're going to talk about what is cold and hot stream in a bit, but these are some of the argument for adopting flow. And there are few more points. So flow goes very easy in terms of integrating with live data, and if you are using Android architecture like view model and all those stuff, it goes really easy with the live data. And it has got a back pressure support. So what I mean by back pressure support is, uh, if you are familiar with Rx, you there is this disposable thing. While using Flow, you don't need to worry about disposing your subscription. Since Flow works with the suspendable function, it automatically takes care of it. So here is the coroutine will come, and Flow are built on top of the coroutine. So you don't need to worry about back pressure. That's one more plus point. Also, it has got multi-platform compatibility. So Flow is written in pure Kotlin, and Kotlin is multi-platform. So imagine you are writing an API or something in your iOS which using shared code mechanism. So you can get benefited by Flow as well. And then I think dev community was literally missing something like this, which is purely written in Kotlin, and they can just bring their entire application into fully Kotlin stack. And I was initially talking about that flow is cold. So here is more about what is cold and hot stream. So there is channel. Now channel is hot. So when I say hot stream, that means even if you are not consuming the data would be continuously produced. So I feel there is bit of a overutilization of the resources. And then with flow, it is cold. That means it only start emitting the data when you use the collection. So there is a collect operator which is known as a terminal operator. Until and unless you ask for collecting the stream, it won't emit the data. So that's the difference between hot and cold stream. Hot is like eager emitting. It will just keep on emitting data even if you don't consume it. But cold stream is, it will only emit the data if you demand it. So that's the fundamental difference. Okay, so if we want to start with the flow, how do I start? What's the first step I should take to start using the flow? So flow comes as a typical dependency in Gradle along with the coroutine. So you don't need to add any extra dependency in your project. Just add coroutine, and if it is an Android project, add the coroutine Android as well. So by adding these two dependency, you will get the all the flow API in your code base. Now imagine there is list of strings. Now how do I treat this list of string as flow? So to convert this list of string in flow, what you will do is you will simply use flow as a lambda function and then write emit and then whatever is your property or object, and it will just convert everything into flow. So your list of string is converted into flow. Now there is this little extension function. So we know Kotlin is all about beautification and syntactic sugar. So there is this as flow extension function which is written on iterator class. So if any iterator can be converted into flow just by calling this as flow function. On top of that, there is also a flow of function. So what if I just want to convert anything into flow other than iterator? So for that, I would use this flow of function which takes argument of type t and then convert anything into flow. And flow needs to be collected. We'll learn about collect operator in a bit, but keep this in mind. And then there are these various operators in flow. So we'll start with the simple operator first, and then we will understand few of the really interesting operator which flow offers us. So operator, why we have operator work on the data which is emitted, and it help us to transform them before they are actually collected and used. So that's the main job of operators. Imagine there is this piece of code. We call it a function called flowing river, which ultimately continuously emitting some sort of data. We call it water. Water is, imagine it, there is some simple data class which holds some sort of value in your application. So we specify a return type as flow of type water, and then we provide a body which is a lambda style function. I say flow, and then into as a lambda parameter, I will put my while loop and then basically an emit function. So emit function is the key. Until and unless you emit, you can't receive anything. So emit is the key. And how do I collect it? So there is a flowing river, and then on top of that, we just add a collect operator. Collect operator receives an extra argument. It can be named anything, value or response or whatever you need, but it will receive the same data which is emitted, and you can do whatever you want to do. Here I am simply printing it, but it can be anything, sending something on a view or maybe doing further processing. Then there is a famous map operator which I think very widely used. So there is a flowing river, then we map it. So map simply transforms the data. So if you emit string in map, you can transform to any other thing based on your logic. So here I am translating into something else. So map transforms data into something else, and then using again a terminal operator which is collect, we receive that value and we process that value further. So that's the whole relation and philosophy of collect in along with your flow. I'm again saying until and unless you collect it, you cannot receive any emitted data. Then there is a filter operator, which is also very basic operator. It doesn't need any more or detailed explanation. So we have map operator. We can change it further to filter operator. So there can be chaining. So those who are familiar with RX, they can easily relate to this. And then there is a filter operator. In filter, it requires a Boolean expression to process. If it is true, it will send the data further. If not, it will skip that data. That's simple. And then this gets collected further using a terminal operator collect. And then here we are just simply printing it. So those are very simple map and filter operator. There are few complex operator as well, which you might want to use. This is something called buffer. So imagine a situation where both emit and collect, they take some time to execute. So imagine emit is taking 1 second of time, and collect is taking 2 seconds of time. So collect is a costly operation in your application, and it is taking time, but flow is sequential. So what will happen, they emit the data, something get collected, a new data is emitted, a new data is collected. This is the flow. That's why it is called flow is sequential. And buffer can be a great help, and they can reduce the overall time. We'll see how it can help us to reduce overall time. Basically, they internally use a concept of channel while emitting the data, and then while you collect it, they use this another coroutine context. This is how the entire buffer operator works. We would try to understand it in with some sort of infographics. So let's say data 1 is emitted, the data 1 is collected. Now imagine data collect operator is taking more time, and meanwhile the new data got emitted. So buffer operator will respect time what collect operator needs and will not provide a new data to it until unless the collect operator is finished. After collect operator is finished, it emits the new data from the buffer operator. So this is how it goes. And meanwhile, any new emits can be just keep going into the buffer. Buffer will hold those emitted values and only send it to the collect operator once the collect operator is finished. So that's the core about buffer operator, how it looks in code. So imagine there is a download video function and you are emitting some sort of data. So I'm using delay function just to simulate the entire situation. So we emit value, we got delayed further, we emit one more chunk of data, and so on. So we keep on emitting data on some certain delay. At the end, what would happen here, if imagine I'm not using buffer operator and I'm simply using collect, then when I did this test run, it took around 8 seconds to complete this entire flow. And then when I use buffer, it simply reduces the time because your emission will take place on another channel, and then your collection will take place on another coroutine context. So that's where the time get saved, and I got to finish my task roughly 4 seconds. So you can see whatever time your emit function is taking, that can be saved if you use buffer. But you don't need to use it in every case, only use it if there are any delays happening in your emit, or if emit is a very time taking task, then only use the buffer. In normal scenario, we won't use buffer. Another interesting operator is combine. So when you are dealing with multiple flow, this combine operator will help. So what I mean multiple flow is, let's say there are two functions which are returning flow and you want to work on both the flow because there is a requirement in your application. So you can combine the result of two flow using combine operator. So name is pretty logical, and the emission happens in parallel and you can bind them. It allows you to transform the emitted value as well before you finally collect it. So we'll see the same behavior with some more infographics to make it easy in terms of understanding. Let's say there is emit 1 and emit A. So there are two parallel flows going on. One is emitting number, another is emitting some alphabets. That result is collected further using combine operator. Now there is this emit 2, which is taking slightly longer time than the usual, but emit B is finished early. So what would happen in this situation? Combine usually picks up whatever is the latest result available in both the respected flow. So the result would be a combination of collect 2 and B. Now imagine meanwhile there is another emission happen from emit C. Now emit 2 is still going on. So the result would be it takes the latest value of emit2 and a new result is generated which is called 2nc. So this is the result. Because emit2 was going on while emit-c was emitted, it refers to emit2 and it generates a new result. Similar, if this problem is extended further, now let's say emit3 is happening, but emit-c is going on. And as you can predict, it would be result of emit3 and emit-c. And then if emit-d is happening, it will be result of emit3 and emit-d, because emit3 is still going on and it is latest on the flow 1, and on the flow 2 latest was emit-d. So the new result should be 3 and d. Again, it's time to look into the code how we can actually do that. So imagine there is this function, we call it get unit values, which returns us some sort of flow. There is another function, we call it get ingredients, which also returns flow. And now our requirement is to merge them and get a combined result. So how do we use combine? So here we say combine operator. So there is this main function called get unit values. I am again slightly adding delay just to mimic the actual scenarios. And then I call combine operator. I pass another flow, get ingredients. So this is how you combine two flows. And then it generates a value. You can transform this into anything. I am transforming this into a string, but it could be your data class or anything. You can pass it to some other function based on your requirement. So you can utilize this space to transform your data or bring it to the form in which you need, and then ultimately you collect it. And then again, after collection, maybe you would like to pass it to your view to display it on a list, or maybe to some sort of detail screen. You can do whatever you want after you collect it. Similarly, there is a zip operator as well. This is similar to what Rx has, and it combines values emitted by two separate flow. But there is a slight difference in the way combine operator works and zip operator works. It will not emit final value if the corresponding emit is not found. So imagine there are two flow. If flow 1 has emitted the value but flow 2 hasn't, then it won't be creating any result because it is expecting the corresponding emit to happen. If you understand with the infographic, let's say there is emit 1 and emit A, so you get result as A and B. Similarly, emit 2 and emit B, you get result as 2 and B, and so on. But now imagine there is this emit 4 and nothing get emitted from the other flow. So this result will not be collected. This thing you have to keep in mind while you use zip operator. So mostly it would be your even number of flow emission. If it is an odd number of emission, some emission would miss. Mostly it would be your last emitted data which would be missed and won't be collected. And this is how you use it. So instead of combine operator, use a zip operator and then just pass on your another flow and get the result back. You can again transform your result to whatever you need, and at the end it got collected. Okay, so this was the introduction for basic operator and how you can use flow. But these are all the best scenarios which we consider. And in this year 2020, we have learned enough lesson why we should plan for worst. So let's say what flow has to offer when it comes to error or exception handling. So basically, flow offers you a mechanism to handle your exception runtime problem when your emitter or collect or any other operator goes nasty. Let's see how it works. So there is this function which, let's say there is a flowing river and there can be some sort of error. So I have written some logic where if the dam capacity is 50 and the water level reaches to there, it should just throw an error. So I can use try and catch basically to handle the exception, and then I can either throw the exception from try or can just listen whatever is happening inside try. And if try throw an error, it will ultimately come to a catch block. You will get instance of exception. This is a typical try catch what Kotlin is offering us. It has nothing to do with flow. And then we receive the final result in a finally. It can be optional, but this is not good in terms of code structuring, or this looks little ugly. So there is a better way which flow is offering, and there is a catch operator which they introduce. So catch operator cannot be just placed anywhere. There is a concept called exception transparency, and this catch operator will catch all the exception which is happening preceding to that. So whatever is happening before catch operator, it will catch all the exception. Sounds good? So let's say if on each, in this example, on each is throwing an error, then the catch will caught that error. If there is a map operator or filter or any other operator, whatever is throwing an error, they will get caught by the catch. Now there is a slight glitch in this approach. If you think further, what if there is error in the collect itself and something goes wrong and collect is throwing an exception? Will that be caught? So answer is no. For that, you slightly need to change your implementation, which is called a declarative approach, where you move your entire logic out of the collect and move it to some other operator like on each or something. So if you see, compared to previous example, I have a println statement in catch collect, and I'm moving into on each operator, and then there is a catch operator below it. So I don't need to worry that my collect will throw any exception or not. So I have smartly moved my logic into some another operator, and then I can just call the collect function freely. Okay, is there any way I come to know about how, when, and where the flow is completed? So the answer is yes. Flow provides you two different ways to be aware of when the flow is completed. The first is called imperative collection. We basically call again try catch and finally, and at the end finally will be called, and you got to know that flow is finished. But we are not satisfied with this syntax, and as I said before, this looks ugly. So there is this on completion operator introduced by flow, and this on completion you can again easily relate with the Rx. You will get notified here when the flow is finished. Now on completion has something interesting in it. If you observe, there is that parameter called cause. So when the flow is finished, and you will receive this cause parameter. If this cause parameter is not null, that means there is something wrong. There is some error happening. That's why you have some value in cause. And if the cause is null, that means there is no error, flow completed without any error. Okay, so we talked enough about basic flow, how it looks in Android. That's what we are interested in. So let's see what we need to do if I'm an Android developer and I want to use flow. So I have taken a small use case for this. Okay, and the goal is to create a small application where I would be using some of the concept like architecture, component, means live data, and view model along with the flow. And in original example, in original application, I was achieving everything using Rx, but now I want to migrate, let's say, from Rx to flow. So what else I should do if I want to use flow for my application? So I have kept the example very simple and covering one base case scenario and one error scenario. So imagine there is a function which you have written in Rx, which returns a kind of a single, and then you get the response back. This get converted into like this. What is new in this is a suspend function is introduced, and then there is a return type which is changed. So we don't need now single or observable or anything. we just use a simple type which is called recipe list response. Now in this repository implementation, I'm using repository pattern to make an API call. This is how it looks in RX Android. So I return a single type of recipe. Further, I transform that data into something else as per my application need. I use some operator to get the data what I need. I have some sort of error handling inside do on operator, as you can see in the code. And if this has to be converted into flow, what it will look like. So this is how it would be changed. You change the return type to flow of recipe, then you convert your simple data into flow of recipe. This is the function which I have created because flow of was giving me some strange error. So I just add a wrapper function on top of it and then simply emitting the data. And at the end, do on error becomes catch. So I do the same thing which I was doing in do on operator. I do the same thing in catch operator. So this was the repository bit which I did. Now, if I think of a view model, so this is how my view model was looking when I was using RX Android. So I was subscribing my repository call on this, and then I was showing a loader and I was doing error handling. And at the end, I was disposing it. If something goes wrong, if user moves on to another screen, I just dispose it. If I change this to flow, how it would look like. So this was the new code which got generated after I used flow. And this was the first change I did. I converted everything into live data of recipe, and then the entire bit got changed. So there is this on start. On start will tell you when the flow is started. It is something like do on subscribe. It is similar to that. And then there is this on completion, which will notify you when the flow is finished. There is this sketch. I added this error handling just to transform my HTTP exception into more meaningful business exception. And then I just call as live data. As live data is an extension function provided by, I think, one of the KTX library we have for live data. So there we have got this extension function. And from this, my entire flow can be converted into live data. And this live data is, of course, observed on the view layer, which would look something like this. So we have a fragment, recipe detail fragment. I have this view state hour fragment, which is nothing but the abstraction part of the way I do error handling and the way I show progress bar. You can find it in the main example, which I would be sharing after the session. And then I created a view model. I am using Coin for the dependency injection purpose, and the view created on view created function. I simply call my API and then observe it. So I call view model to whatever is the function. I pass the required data to it, and then I observe them. And once my observer has the result, I show it to the view using show recipe detail function. Similarly, if that was the success scenario, now what if there is an error scenario? So as I said, inside view state aware fragment, I have written some abstraction layer for my error observer and progress observer. And this is just I'm overriding that value and do whatever I want. So I can do error handling in my own way, maybe in a different activity, because I can override them. So I can slightly tweak the behavior according to the screen I am. It's a bit of a flexible. So that was pretty much on the main code side. And then what if I want to secure my code by writing some unit test? Is unit testing really easy in Flow or not? Let's evaluate. So to set up your unit test, it's pretty much simple as you do in your existing project. I'm using mock-k for the library. So I say I'm mocking the repository and the service layer. Sorry, this is the repository test. So I'm only mocking the service layer and not the repository class. because that's under test, which I shouldn't mock. And then I just set up my mock annotations. So I just initialize my mocks, I initialize my repository, and then further, here is a test I add. So I mock the behavior of the actual API and return some dummy response by using this co-every function. Co-every function is a function which can help you to mock anything which is inside a suspendable function. If you are familiar with the mock k, the typical every function won't work for your suspendable function. You have to use co-every for that. So it is for that. And then here is a bit. We simply say run blocking test and then recipe repository dot search recipe by ID and first. So in actual code, I was using collect as a terminal operator, but it could be first as well. So let's say I call first, I get the result back, and simply I assert. So whatever is my expected recipe, which I might have defined in my test data, and then the recipe class, recipe object, which I received as a this repository call, and that's it. This is pretty much for the success scenario test. It's key thing only one. You just need to write your actual code inside a run blocking test, and then that function would manage everything. So there is a coroutine test dependency which you need to add, and that would do the job for you. Let's see how we can assert if there is any exception. I was actually using JUnit 5 while I write this application. So I have removed but unnecessary stuff. So it would pretty much look like a typical unit test. So let's mock the behavior. If there is an API call for get recipe by name, I would throw an exception called no internet exception. And then I would use assert throws. So this is the exception, or this is the function which is part of JUnit 5 library. And I would use run blocking test one more time. I call my actual function inside it. And then this is how I assert whether the exception is thrown or not. So I say assert true and exception is instance of no internet exception. And if it is throwing the same exception, my test would pass. Otherwise, my test would fail. And that's why I would come to know if anything is missing. Then there is this one more useful extension function, which I think I should share with you. So there is a flow on. Now, if you can relate everything with your Rx, there was a function called subscribe on and observe on. So similarly, there is a flow on function for us provided by the Flow API, which is quite similar to subscribe on. It is basically used to change the context within the flow. So by default, your flow will run in your coroutine context. But if you want to switch the flow in between your flow or collection is happening, you can use flow on function to switch the flow. And main thing to remember is when you use flow on, the flow on function will only be applicable for your preceding operator. So anything below flow on operator won't be applicable for the context which you are passing in flow on. If you see the code, maybe you can try to visualize it more. So here is a piece of code I have called flow on function at the end. So I'm saying I want to execute this flow on a IO thread, and it will offload everything which is a blocking kind of a behavior to an IO thread, which is a non-blocking thread. So this is how it would be managed, and anything above flow on operator will be executed in IO context of your coroutine. There is slight variation which flow on provides called flow with. Now this is very typical function you may not use in your day-to-day application, but this was interesting and worth sharing. So it is used to change the context within the given block and set of operators. So what do I mean by given block and set of operators? And let's see that. And it does not affect anything outside that block. So if you see, I don't have any exact example, so I just grab that example from the official documentation. So let's say there is this flow which is running on, and then there are two map operators, which is one is above the flow width, another is below the flow width, and I say flow width dispatcher.io. So the flow width will only apply that new context within that block. The previous, the precedented block and the subsequent block will not be affected by this new coroutine context. They will still be running in their original context, whatever we have specified, and only the block within flow width will get the new context. So that's the main difference between flow on and flow width. Something to remember if in case it encounters somewhere in your application. And then we saw as live data how it works. It is very great function, and it will keep your code beautiful. Otherwise, if you want to switch from flow to live data, you might need to write some ugly syntax, but this extension function is a great help. And there is also an extension function available in the same ktx library, where you can convert your live data into flow. I can't think of any scenario where you would be converting your live data into flow as far as the Android application is concerned. But again, if in case there is an operator, and there could be a scenario which I cannot think of or I cannot encounter in my application. But this is something good to know, that you can convert your live data into flow as well. So it's both the way, basically. And there cannot be any more limit on any of the extension function. You can build any other function which you want, and as per your need, while you use flow. So that's all from my side for the flow. You can find the source code in on this link. So Kotlin flow sample will cover a pure flow related example, and then there is a mill recipe app where I have pushed all the Android related example which I showed you today. It has two branches, and there is this readme as well, so you can go and have a look and try to fiddle around those repositories. Hopefully it would be helpful for you guys. Before I say bye, there are some key takeaways. So again, why we should use flow, or why should at least give it a go in your application. So it provides very focused set of operator. We know it is not as much operator compared to rx java, but it's just matter of time, I guess. And sometimes also it helps if you have a focused set of operator which does the job. There is no need to you know add the heavy library which has lot of other things as well, but not of your use. It is stable, so you can use it in your production application, and it has a really easy integration. There are lots of blogs available which you can refer to use flow along with your architecture component, mainly live data and view model. It is easy for unit testing. No basically bullshit around trampolining stuff, setting up rx and everything. Just use run blocking test, and that will do the job. Back pressure support, this is very critical and important feature according to me. You just don't need to worry about disposable. We keep on forgetting that, considering a disposable while we work on rx java, but I think flow is a great when it comes to the back pressure handling. And it's multi-platform, so you never know when you will unleash all the power of Kotlin as a language, right? You can leverage flow if you are using Kotlin in your API project or iOS application, or maybe native code. Why not? So yeah, keep the big picture in mind, and just go with the flow. That's it. Thanks for your time, and you can feel free to ask any question now on Slido, or reach out to me on Twitter.
Thanks. Thanks, Hardik. I think we have a couple of questions, so they're gonna pop up in a moment. Just give me. Yeah, so
Mhm.
a couple of questions. Yeah, there you go. So if you can read it and answer it if you want. Yeah.
Yeah, sure. Let me load those questions. I can't, let me, okay.
I can read it to you if
I
you have
somehow,
an issue.
yeah. Can you please me to read
Yeah.
those question?
So the first one is, do you use Flow in production? Would you recommend to replace RX with Flow in complex projects?
Okay, so the project on which I'm working on is pretty big. We haven't started using Flow in particularly that project, but I would surely recommend. And the approach I would take is maybe I would try with the smallest possible module and see how it goes. You don't need to replace Flow in one go in your entire big application, right? You can take a step-by-step approach. So let's say simplest module can be a profile section or anything. It depends on your application, but I would definitely recommend in Flow. Even if it is a complex application, you can take the step-by-step approach. It is fully stable. There is also one more bit which you might want to consider. I don't know what exactly Rx operator you would be using, because Rx is full of operator. But if you are using simple operator like map, plat map, and stuff like that, I don't think there is any risk switching to Flow.
Cool. And the second is pretty much connected to what you just said. So is there any operator of RX Java that is not available in Flow? I think it's probably specific to like a more complex, if you have an example.
Mm, so Rx Java has this thing, right? So there is a single, and then there is a completable, and this kind of uh, calls. So I think it won't come as easily. So imagine you are using completable. So what do we what do we do in that case for Flow? I haven't particularly explored that way. What if you are using completable or something like that? But one thing I can say that with the single and observable, I have tried this two thing. That's what I use mainly in my application, and that come out very very nice and smooth. But I'm sure the Rx has a lot of operator. Flow definitely don't have all the operator which Rx has, and it's matter of time.
Cool. Thanks, Hardik. Thanks so much. I would say just like it's been 6 months in the making, this talk. You contacted me like 6 months ago to
Yeah,
want to talk to the meetup. And then we had the lockdown, we had to do stuff, and finally we get
yeah,
back and we finally had this talk. So
yeah.
very
We
happy to have
finally
you.
made it, and I hope it would be useful for the
Yeah,
community and all
absolutely.
the
So
viewers.
yeah, there's a lot of interest in Flow and myself as well. We're talking about in my company to switch between from Java and Flow. The other things is that we still have some Java code, so
Yeah,
we first have to convert to Kotlin, and then we can embrace Flow fully,
yeah.
hopefully.
So this was more of a introductory session, and if we see interest of community, maybe we can have a much more dedicated session on how we can migrate from Rx
Mhm.
to Flow.
Oh, that would be cool.
Yeah.
Yeah. Thanks so much, Hardik.
Thank
So,
you. Thanks, everyone.
yeah. Cheers. So, just as I think the 30 second that we can switch to the second speaker. And then we go with Sebastian Aigner, who's going to talk about a full stack web application, of course, with Kotlin. So just a bit like a 30 second, I think, while we switch to the Sebastian.
All right. Yeah. All right. Hi, everybody, and thanks for tuning in to my talk. I titled it "Unleashing More Kotlin Power" because, as we all know, Kotlin is already pretty powerful. But this time we're talking about the context of full stack web applications. So before we dive into this, let me just super quickly introduce myself. Hi, I'm Sebastian, and I work as a developer advocate at JetBrains. I mainly focus around topics concerning Kotlin and Kotlin JS. And I would say that recently, most of my work actually revolves around Kotlin JavaScript specifically. And while it's not quite as popular as some of the other targets for Kotlin just yet, I think it bears immense potential. So I kind of try to share as much knowledge about it and kind of get people excited about it as much as I humanly can. So as you can maybe already guess, since this talk will be about web applications, we'll definitely see some Kotlin JS tonight as well. So I really wanted to present something that you folks probably haven't tried before, and something that might come in handy for you sometime down the line. So I've really done my best to kind of cram all the parts into this talk to make good on the promise of the title for the full stack application. So we're going to see a little bit about a server, a client, the multiple execution environments. I think it's going to be a blast, and hopefully we'll all learn something new along the way, especially you folks. So what are kind of the goals for this talk? Well, so I'm going to walk you through a mini example project, first of all. I kind of want to provide a rough but realistic overview of the typical tasks that are involved when you are building an application that consists of multiple components, and then also really dive into the implementation details for such an app as well. And in a later part of the talk, we're also going to see how we at JetBrains are actually using a similar approach to kind of what I'm walking you through, both for very small products like just internal hackathon projects, all the way to our newest products that we're actually shipping. So I hope that I'll be able to instill some excitement in all of you when it comes to the tech, and ideally to the point where afterwards you'll go hands-on and try some of this stuff for yourself, even if it's not in production. So without kind of further ado, let's just build something, because that's probably the best way to learn something. So the example project, I really want to keep kind of simple and really constrained to the essentials. So what I kind of want to propose is a small shopping list. So just a simple input field that allows you to add a couple new entries to the list, and the option to just click on them and have them disappear to tick them off. So as a really small cherry on top, I'm going to replay this animation again. We can add a couple of exclamation marks while we enter an entrance, and we will just parse these exclamation marks and generate a small priority number based on it. So of course, since this is supposed to be a full stack app, we want to send all this information to a server, and then ideally persist it there so that if we access it from multiple devices, right, or if we access it over multiple reloads, we always see the same shopping list. So let's kind of formulate a game plan based on this. For something like this, what you can probably imagine a basic architecture to look like is something like this. So on the left side, we start with everything that runs on the server. There are tons of server-side frameworks for the JVM, so we'll choose one of those, and we'll implement the whole backend in JVM code. Ideally, at some point, it should also integrate into some kind of database, though for the purpose of this exercise, we can always just mock that part. More importantly, we of course want to expose some kind of HTTP server, and we need to somehow serialize and deserialize our model. For that, we need to agree on some kind of common description or abstraction for our model, which is going to be the elements in our shopping list. And then if we go quite symmetrical over to the client side, we need to make sure that our system over there speaks the same language, so to say. So it needs to be able to serialize, deserialize the same models, make requests to our API, and of course, include all the logic for the client as well. Because modern web browsers all speak JavaScript, this makes sense to have this written in Kotlin JS. So since we want to build all of this in Kotlin. We also want to make as much use of code sharing as possible, which is why we would define our shopping item model in Kotlin common code. So just code that's pure Kotlin, doesn't use any platform-specific libraries to define our model. Now, when we start translating this into kind of the structure of our source sets, we get a very similar pattern with just 3 source sets. All our code for the JVM backend goes into JVM main. Frontend JS code goes into JS main, and code that's platform agnostic stays in common main. So now that we kind of have a basic idea of how we want to structure the app, I would say it's time to actually start implementing. I usually like to start with developing the actual service as an API first, because then I know what kind of data I want to and can actually offer to my clients, and then how I can pull those and we can tackle later. So let's do this. As a first step, we kind of need to agree on a framework that we can use for the server side. On the JVM, there are tons of different libraries that can help with spinning up a backend service with Kotlin. Because, well, as a JVM language, all the Java frameworks can, of course, also be used with Kotlin. And sometimes they even offer specific support for Kotlin, which means we could write our application with Spring Boot, Javelin, or Spark. But there's also members of the Kotlin community building frameworks like HTTP4K, for example. For this demo project, I'm still going to choose Ktor, though. So if you haven't heard about Ktor yet, everything you need to know is written in its tagline. It's easy to use, fun, and asynchronous. And I mean, if it's fun, then what else are we supposed to do? No, what I really enjoy about Ktor is that it's a very unopinionated and modular framework, which means we can write tiny applications like our shopping list without having to wade through tons of configuration or annotation black magic, but we can still expand upon this, and we can still build even more complex systems without running into any kind of bottlenecks that Ktor would produce. Another cool thing about it is that it's an official JetBrains project, which is an added bonus because, as we'll see in a bit, it's actually also a multi-platform project in itself, and it integrates really well with some of the other official libraries we have, for example, Kotlin X serialization. If you've never touched Ktor before, let me just give you the world's shortest Ktor tutorial. To spin up a very basic HTTP server with Ktor, we include the relevant artifacts in Gradle first. Then we start an embedded server, in this case just on port 8080, and we use the routing DSL to say that any GET request to the /route should be responded to with hello Ktor. One button press later, once we hit the run task, we have a backend. It's not quite the backend we need yet, but it's already a backend. So at this point that we know that we can respond to things quite easily, it would make sense to agree on a minimal interface to kind of know what operations we want to support, and then later translate that into the web user interface. So typically when people write these demo applications, they build CRUD apps, CRUD, which stands for create, read, update, delete. Honestly, if you've seen the demo beforehand, updating isn't really all that important to us in just a shopping list. So we are going to have a CRD or CURD app. So we're just going to focus on these 3 types. For our shopping list to work properly, we first need to be able to add new entries, right? Which we would do with the post method, and then we'll just post some JSON there. In order to display the list in the front end, we would also want to support a get on the shopping list, which would ideally return a list or an array of all of our shopping list entries. And then finally, given a specific ID, however, we'll define that later, we also want to be able to remove individual items as we tick them off. So we have a mental model now what our API is supposed to do. We've kind of already agreed on the JSON structure as well. So it's time to define our model. And this is the thing that we want to work with and also send over the wire in the end. So we already kind of know that we want to share our model with our frontend later on. So what we can do is we can take this simple data class we have here, and we'll put this into common code, which means we'll be able to access it later, both from Kotlin JS and from the Kotlin JVM side. We are also going to be a bit clever here, and inside a companion object for our shopping list item, we are actually going to associate a path with this class. Now, why would we do this? Well, we can use the information for this later, both on server and on client, to kind of make sure that both of the sites use the correct URL when they access items of the type shopping list item, right? So this is going to prevent a bunch of possible typos down the line. We'll hopefully see that in a minute. So before we move on to kind of exposing all this data through our API, we still need to have kind of a way to convert our Kotlin object to its, well, JSON representation. And we're going to use Kotlin X serialization for this. If you haven't heard of this library before, it's essentially a library that allows you to convert Kotlin objects into their textual representation and back again. Now, for enabling serialization for a simple class like our data class here, after we've added the Kotlin X serialization dependency to Gradle, it's literally just adding a single annotation, and we are done with this. Now that we kind of have the common part out of the way, we can actually get back to writing the JVM server. And I've alluded to this a little bit already before, but I'll be happy to say it again. Lady Luck is on our side here because Ktor really loves Kotlin X serialization. So we can kind of follow the instructions on the Ktor website, and really all we need to do is add 2 lines to tell the Ktor backend that content negotiation should be enabled and that JSON should be used as an exchange format. Now, Ktor automatically configures Kotlin X in the serialization in the background for us. And pretty much all that we are left with are 2 new powerful ways to communicate. Because now when someone gives us an HTTP call, we can either respond with a Kotlin object directly, of course, provided that it's serializable, or we can just receive a Kotlin object directly. So the whole serialization, deserialization shebang is abstracted away from us, which in my opinion is quite delightful because it makes our job of implementing our 3 HTTP methods so much easier. In fact, besides the few lines of configuration that we saw beforehand, everything you see on this slide is the whole business logic we need for the backend. So let's assume for a moment that we just have a collection of shopping list items called, just shopping list. Again, for the sake of demonstrating, this could just be a mutable list that is stored in a top-level declaration on the server. But the amount of work that you would have to go through to replace this, for example, with a MongoDB instance is absolutely marginal. It wouldn't make much of a difference here. But let's actually go through this line by line. So inside our routing block, we first group all the routes by the shopping list item path. So all the routes that are inside this block, they will be children of the /shopping list route. And now if someone calls get on /shopping list, we respond with the collection of shopping list items. Ktor and serialization in the background then make sure that everything gets turned into the proper JSON form. And yes, as you can see, it even works for collections or lists of serializable objects, like in this case. Now, how do we handle adding a new item via a post request? Well, in kind of the most straightforward way, we can just receive the item again as a Kotlin object, add it to our collection, and respond with an HTTP OK. And deletion, well, is the most complicated of the 3 because it is actually 3 lines of code and not just 2. We turn the parameter first into an integer, remove it from our collection, and we are done. So as you can see with Kotlin X serialization, working kind of as a team with Ktor, all the grunt work has kind of been abstracted away, and we were able to describe our whole setup in just a few lines. It's ready to spin up. So at this point, we can actually move on to writing a web client at this point. So let's first kind of move on to structuring our front-end application that looks a little bit like the one in the video I showed in the beginning. It's probably best that we first get either a basic understanding or a little refresher on how a Kotlin.js project works. So first of all, we need to have some kind of home for our JavaScript application, some kind of HTML page. That's just because we can't have free-floating JavaScript files that are executed in the browser. They need to be in a site, even if all the site does is include the JS file. Then we, of course, need to write an application, app.kt in this example. If we want to, we can, of course, also include artifacts from common libraries, which we're going to do. And once we funnel all of this through the compiler, we end up with our index.html file and the corresponding JavaScript file in our output build folder. This is already nothing too complicated, but it does show us one issue because we are building a multi-platform project. So we don't really want to have to manually copy around the resulting JavaScript files just so that they can be served from a server somewhere. No. So what we want to do is we want to serve them with Ktor as well. What needs to happen really in the background here is that we need to, when we build the Ktor application, we also want to compile our JavaScript frontend, then copy the resulting artifacts into the right directory, and then run the Ktor server, so that it always kind of runs with the newest version of the frontend and works well together. Might sound complicated at first, but thankfully we have a strong ally, everyone's favorite elephant, you guessed it, Gradle. So all that's kind of needed to do the inclusion is described in the snippet. If it looks a little bit scary, don't worry. First of all, it's not like we have to kind of come up with a snippet on the spot every time we want to change something in the application. It's closer to like a one and done thing. The really interesting parts of the snippet anyway are these two lines where we just make sure that the artifacts for our application are created and included in the build when we run the JVM application and build it. Apart from that, the snippet is just minor optimizations between production and development mode and making sure that all the class paths are adjusted properly. At this point, we will already have our front-end application, if we ever build one, available in the resources of our Ktor backend. And we can serve those files once again by adding 2 significant lines, 3 lines in total, to our routing block of our Ktor application. So now if someone would visit the index.html at the root of our API, they would see, well, currently nothing, but at some point they will see our front end there. If you want to have URLs that are even prettier, that don't include the index.html in their name, we can, of course, define the appropriate rewrite, access the file directly. That's certainly going to work. So finally, it's time to write some actual Kotlin JS. First of all, we can start with writing the counterpart to our JSON API. So because if we have that already, we can kind of rush out the user interface in one bit. We can wire it up directly. So I may have briefly already spoiled this slide before, but the Ktor project actually isn't just server-side stuff. It also includes Ktor clients, which are available for multi-platform, meaning that with a very similar API to what we had beforehand for the server, we can now use them to make HTTP requests, but they also have features like WebSocket support. And again, they work wonderfully with Kotlin's concept of coroutines. And yeah, in case you did not know beforehand, coroutines are multi-platform, which includes Kotlin JS. So we can just use them in our front end later on without giving it a second thought. And by the way, of course, if you are interested in doing Kotlin Flow, that is also going to work in Kotlin JS. Now, everything we're kind of doing on the client side is going to be very symmetrical to what we've done on the server. So I don't want to spend too much time on it, but I just kind of want to show you the symmetry, right? So first, the counterpart for content negotiation on the server is the JSON feature on the client, needs a single line of configuration to tell it to work with the Kotlin X serialization library on JS. From here on out, we kind of just define the CRD methods. In our case, we call them get shopping list, add shopping list item, delete shopping list item. To keep it a bit more generic, I've introduced the variable endpoint in this code snippet, but honestly, as long as you're just working from the same host, you can just go directly to localhost 8080 or wherever you're hosting your application. So from an implementation standpoint, there shouldn't be too much of a surprise here. It's get, post, and delete methods. Yeah. And this is the second time where we actually reuse the shopping list item path, which we defined beforehand. And I think, again, this is actually kind of a clever thing to do because if you look at this API client, you can kind of see that there aren't really any strings for endpoints in our API, which has this lovely side effect that if we at some point decide our shopping list is actually more a to-do list, then what we can do is we can go to the common code, refactor the name of the endpoint, recompile the application, backend and frontend will both know the new endpoints, will be perfectly in sync, and serve and consume items on the /to-do instead of /shopping list, for example. Well, now finally the time has come to build something visible, so a real front end for our application. As a framework for this, we can use React, which is a good choice when working with Kotlin, simply because JetBrains actually provides type-safe wrappers for React and its APIs. So you can kind of see here as well that the h1 tag, it hints at the fact that there's also a type-safe Kotlin DSL going on here, which allows us to describe DOM elements. We'll see a little bit more about that later. So yeah, the simplest Kotlin React application looks a bit like what you can see here on the screen. Of course, not much is reacting yet. So let's kind of decompose the application that we plan to do and then replace kind of this hello world code just with the snippets of the individual components. So let's have a look at the screenshot again, see if we can figure this out. So in general, we need to hold our overall application state, and then we can decompose our project into 3 components, if you will. So a static header, then the list of entries, and then an input field. Now, unfortunately, I don't have time to dive too deeply into the concepts behind React, but I hope that with the code samples I have on the next slides, things will still stay pretty clear. The nice thing about the fact that the Kotlin wrappers also support the more modern features from React, such as hooks, the code snippets are quite concise as well, and are I think rather easy to grasp. So first, let's start kind of with the application state, which is just a functional component. Really, all that we are doing here is we are defining a state container for shopping list items. So the other thing we want to do is that when the page first loads, we want to fetch the current state, so all the shopping list items from the remote API using a function get shopping list, which we've defined from in our local API client, and then we just fill our local state container. It might look a little odd when you see it at first, but there's not much black magic going on here that would be too different from if you would write the same code in JavaScript, for example. Then the second huge component is the static headline. This probably didn't even deserve a slide in the first place, but again, it's just a nice reminder that we are actually not writing any HTML when we want to render stuff out. We're not concatenating any kind of strings or interpolating strings, but we have a type-safe DSL to describe our markup. And this actually has another big impact, and we'll see how this comes in quite handy in the next component, because it allows us to mix a description of our markup of HTML with Kotlin logic. So what we can see here is the implementation of the entry list. And how we define it is that we have an unordered list HTML element, which we want to fill with content. So how do we do this? We do it the same way we would always do it in Kotlin. We can just, for example, sort the list first, and then we just create an HTML list element item. So yeah, in the same way, we can also actually directly wire up what's supposed to happen when we click an item. So we want to push the deletion change to the backend using our API client and request the new state. Because we are using React and this kind of React store, once we have obtained the new shopping list items and we kind of put them into our store, then our UI will automatically re-render and update. We don't have to do anything else here. But you can see that it's very easy to mix markup with Kotlin, and it still stays rather clear. You can also see here that using coroutines, for example, comes very natural without any kind of extra ceremony. So we can now display and take items away. So let's quickly add the finishing touch, which is the input field. Now, kind of for brevity, I've omitted the detailed implementation of the input component, but the essential point here is the same. So we, what we do is we provide an onSubmit handler, which does the tiniest bit of logic, then submits the list to the backend before we refresh our UI. Yeah, the logic really is just counting and removing the exclamation points so that they are converted into a priority value, which we have in our shopping list item definition. And once we actually have glued together these components, it's already time to pop the champagne or the cider, because we've achieved the goal that we kind of set out for ourselves. So the overarching process, I hope that we need to get through to do kind of a very basic full stack application has hopefully gotten a little bit more clear. Before we round everything out though, I kind of wanted to include two interesting places where Kotlin JS can be seen in action, one very small and one very big. Let's start with the very small one. In fact, a project that we built within 48 hours during one of our annual JetBrains hackathons in a team of 4 or 5 people. It's called Code Quiz. It's a multiplayer game aimed at helping people test their programming knowledge and, well, of course, specifically the Kotlin knowledge. So the way that it works is that a presenter with a big screen or with a big screen kind of shows a code question, and then the audience who is connected via their phone on a web application can lock in their answers and collect points. Now, architecturally, this is very similar to what we've already described. It's a multi-platform project, uses a bunch of the technologies we've already gotten to know. The main difference here is that it uses WebSocket communication to communicate between the front end and the back end, but still both sides are implemented using Ktor, and all data models are shared using Kotlin X serialization. We do something very special here, or well, we do something that's kind of convenient and that's provided to us by Kotlin X serialization, and that is polymorphic serialization. So we can actually have a sealed class hierarchy of game messages, and we can serialize and deserialize those game messages and send them over a single WebSocket, and everything will still work properly. This is actually a non-trivial problem, so I'm very excited that the folks with Kotlin X serialization have come up with such a smooth solution. The interface then in the front end, both for web and mobile, is written with Kotlin and React. It uses a couple of additional components that we pulled in externally, for example, to draw graphs or to do some animations. So if you've ever participated in a hackathon, you probably know that these are very tough and hard work. And it's precisely why I believe that Kotlin JS and Kotlin multi-platform was very instrumental for us. Well, firstly, most of us were actually Kotlin developers, which means it was, if we had the same language on the front end and the back end, it was easy for people to jump between changing parts in the user interface, changing parts of the server-side quiz management, and everyone could speak in terms that they understood. Because Kotlin X serialization provided us with this type safety through our whole stack without us actually having to agree on like a third-party interface language, it made us a lot more confident in working at kind of related pieces of the code at the same time, and even on the game messages, so the actual communication structure at the same time and as a whole. Because really, it's a lot less scary changing a class when you have a compiler looking over your shoulder, doing what are almost a form of like integration tests at the point where you have multiple parts of your system. And yeah, after 48 hours of prototyping and iterating on this, we had something to show for that we were actually quite proud of. And it paid off. We won the entertainment category in our hackathon, and we've used Code Quiz actually a couple of times since then. Most recently, you could have seen it at KotlinConf. If you were there, you could have come to our booth and win some prizes if you knew a lot of Kotlin. Apart from that, Anton Keks's talk on Kotlin Puzzlers, which is kind of known for its interactivity, that one was also held with Code Quiz at the last KotlinConf. Here's a couple of impressions of how that looked like. Of course, I'm not implying that Kotlin JS will bring you success in your next project or hackathon, but it certainly helped us succeed in kind of a high-stress situation, and maybe you can find a way where it could do the same for you. The whole Kotlin multi-platform journey for us obviously doesn't stop at hackathon projects. We are using currently Kotlin JS inside JetBrains to build parts of our newest product called JetBrains Space. So if you don't know what JetBrains Space is, it's our integrated team environment. So this is supposed to unify the whole development story, right? From team organization, communication planning, but also sharing code, building, and delivering software. As you can probably tell, it's a very complex system that's made up out of a bunch of different components. But the main way that you interact with it is actually through a front end written with React and Kotlin JS. And of course, the Space team also makes very heavy use of code sharing between different platforms, which include JS on the web. Then we have JVM on the backend and native on iOS. There's actually a great talk by my colleague Maxim Mazin, if you'd like to understand a bit more how Kotlin is used in a complex system like JetBrains Space. It's called very aptly Kotlin in Space, and you can find it on YouTube from last year's Kotlin Conf. So just to kind of recap, we've seen a bunch of things today, hopefully some that were interesting and inspiring to you. We saw how kind of Ktor and Kotlin X serialization have powerful synergies when it comes to writing concise APIs and even consuming these concise APIs afterwards. Hopefully you've also seen that there isn't too much magic involved when it comes to writing simple front ends with Kotlin and React. And yeah, you should have probably learned that we are actually building products with this technology, and we are thoroughly invested in it. So I kind of want to end on a call to action, because sitting back and watching me talk is a great first step, but even better would it be if you tried this stuff out yourself. So yeah, give Kotlin multi-platform and Kotlin JS a try. It can be a very fun technology to kind of broaden your horizon while sticking to a language that you probably enjoy. And if you are excited about this kind of stuff, I actually have some great news. The example project that we've walked through in this talk, we've actually also made available on play.kotlinlang.org/hands-on. And there it's actually in the form of kind of a long form tutorial. So you can go through it at your own pace. You can revisit topics you struggle with. It has a lot more explanations surrounding some of the more specific topics as well. And yeah, it also comes with, of course, a template project and a completed sample project, so no one has to sit down and start transcribing my slides. While you're on play.kotlinlang.org, you can, of course, also check out some of the other tutorials we have there, for example, on React and Kotlin JS, or we also have a bunch more on Ktor and writing backends with Ktor, the different ways on how you could organize your routes, for example. And there's just a bunch of learning materials there available completely for free. And we hope that they make your learning journey kind of fun and productive. Apart from that, I can only say thanks a lot for your attention, and let's stay in touch. I really like talking to folks about Kotlin in general and Kotlin JS, I think, in specific. If you want to get some weird tweets in your timeline around Kotlin and web technology, feel free to follow me at sebi_io. I'm also very happy to talk there or via email or on the official Kotlin Lang Slack channel or wherever else you can track me down. Yeah, and let's see if there are any more questions right now. And apart from that, thanks again.
Thanks, Sebastian. Yeah, there are a few questions. I'm not sure if you can see them and you can read it yourself.
I cannot.
Okay. Right, I can read it. Can you see them now?
On Slido? Let me reload.
Yeah, on Slido. But it's fine, I can read it to you.
Yep.
Okay, first question from Justin. Thanks, Sebastian. Does JetBrains have further plans for pushing Kotlin JS support out in the wild with frameworks like React, Vue, and React Native?
So we have very good support for React. I know that there are some community efforts going on to trying to get Kotlin JS to work nicely with React Native as well, but those I think are still in their infancy. The problem with some of the other frameworks like Vue.js, for example, or Angular, is that they usually provide some kind of custom build pipeline that, for example, interprets their markup or their kind of templating language. React has this added benefit that because it uses JSX to kind of build its DOM trees, it was a lot easier for us to integrate, and it's currently the main way. But there are actually also some community initiatives for providing pure Kotlin JS frameworks for writing web applications. One of them that would come to mind is Fritz2. The other one that would come to mind is K-Vision. And these are kind of, they're kind of different approaches, but yeah, they just try to make it easy to write pure Kotlin JavaScript front-end applications with the framework.
So that's another question. Can we use Kotlin JS with Angular?
I think I just answered that.
Yeah.
Currently, so of course, actually, the answer of this is a little bit more complicated than what I said before. You can't use Kotlin JS with Angular as in that you can write your whole application with it. But where we also see a lot of power for Kotlin JS is in kind of a library workflow. So the idea would be that your business logic, for example, you write once in Kotlin, and then you package it as a library that you can consume from Android and iOS, for example, and also from JavaScript. So if you kind of have this hybrid approach, then there's nothing standing in the way for using Kotlin JS with other frameworks as well. You just won't be able to access the framework's APIs in a very easy fashion. The other way around, going from the framework into Kotlin JS, we are working very hard to make this like the smoothest experience you can imagine.
Mm-hmm. And just on the same page, so can we use existing JS TypeScript library with Kotlin JS, such d3.js?
Yes, you can. So there's a couple of ways how you can do this. First of all, the easiest way is the dynamic type. So what you can do is you just in your Gradle configuration, you can type implementation and then npm, for example, and you can just pull something in. At some point, this is going to, you can declare this to be dynamic, which means your type checker isn't gonna do something, but you can use it directly. The other ways that you can do this is through our new experimental project called Ducat, which is the Kotlin declaration converter, which has as a goal to automatically convert the definitely typed descriptions or in general TypeScript definitions into Kotlin headers. If you are specifically looking for something like D3, there is another project called Data2Viz, and these folks actually took they kind of took the ideas of D3 and they ported it to Kotlin and to Kotlin Common, which means you have something that's very similar to D3 available as pure Kotlin code, and then multi-platform and of course JS as well. If you have more questions regarding kind of using these kind of things, I could recommend that you either check out my own talk, by the way, from last Kotlin Conf, titled The State of Kotlin JS, where I go a little bit more deeper into the tooling, or you can wait another 2 days, and on Friday I will be giving a talk called Kotlin JS Today and Tomorrow at the Conference for Kotliners, where we will also tackle the newest developments, also in regards to interoping with the JavaScript ecosystem.
Yeah, and the last one is not a question, it's just a thank you and looking forward for your talk to Friday. You just mentioned it.
Awesome, great. I hope to see a lot of you folks in the virtual audience there. I won't be able to see you, but still.
Yeah, thank you, Sebastian. Well, that's all. So I want to thank you again, Hardik and Sebastian, for being with us today. Great talks. Hope you enjoyed it. Also would like to thank our micro-organizer, Guillermo, who took care of all the streaming stuff. We're getting the professional now. And Amar, who took charge of all the QA. And again, contacted Sebastian, having all around the organization. Thanks so much for tuning in. I hope you enjoyed it. The recordings will be available straight away because we're streaming on YouTube, and it will be available straight away. So if you liked it, spread the word, share your link with all the community or everyone you know. We'd like to build an even bigger community. Please again subscribe to YouTube channel. Check out the Meetup page for the next event. Check out again and follow us on Twitter. And that's it. See you next time.